Welcome, welcome, welcome. All right, a question you probably have always asked is what is a second? And it's 184,600th of a day. And kind of. It's a day is 23 hours, 23.93 hours, which means it's not nearly a perfect 24 hours, which means the second's not nearly, well, it is that, but we have a better way of calibrating this. And our atomic clock, we measure the vibrations of cesium atoms, and basically it vibrates like 9 billion times per second. If you want the exact number, it's in your book, and I'm not going to write it down because I'm not making you memorize it, but it's accurate within less than a microsecond with an entire year. So it's pretty accurate. The next thing we're going to talk about is meters, and the first thing I ask is, what is a meter? And the next thing is, why is a foot a foot? And basically, in the the 1100s, King Henry I was like, "Yo, this is a foot," and that's that. Nothing special, nothing awesome. He just standardized it to make units and things, which is a great idea, but it's so arbitrary and not fun. And then the 1700s of the glorious French Revolution, where everything became awesome, we defined the metric system in the meter as 1/10,000,000th of the distance between the equator and the North Pole. And it came out to a pretty handy size. It's a little bit longer than a yard, and this is the thing that we used to measure our meter sticks across. And that was the standard. That was that. That was the approximation that became the meter. And now we have more scientific ways of figuring out, which we have the light. And hopefully I covered everything that needs to be covered. Oh, by the way, expect the first time. I don't know where I'm going to put this in, but I went on a long tangent about why England and the metric system, why empiric system is gone, but I'm going to keep that out. It was a long tangent and it was unnecessary. But just know, metric system is way better. Just know that. Okay? All right. Well, bye. Right, so it's 3 times 10 to the eighth, not ninth. Ignore the ninth. Um, and it's the that is this is the actual number. 3 times 10 to the eighth is the estimation. This is about how many seconds. I mean, how much light travels in this fraction of a second. So the speed of light would be how many meters does it travel in a second? It travels that many meters. And we'll get into how this works later on. All right, we're just going to try to keep going through this video as fast as possible. So, all right. Anyway, without getting too much into it, it's now set with Planck's constant, which uses kilograms meter squared inverse seconds, which we're not going to get into because I don't want to confuse you guys. But we do have it now universal for the kilogram, and it's using universal constants, like Planck's constant and the meter, which we can talked about. We can define um, with the speed of light, and it uses seconds, which we can pretty accurately figure out with the cesium clock. So with everything, we can figure out. We now have if all of the world was destroyed in a mass uh, apocalyptic event, we could redefine the world and at least have our base measurements so we can figure out science and stuff. Yeah, yeah. That's what we have. That's what at least my physics professor in college told me, is that we would be able to figure out things, which is important for all the science work we have so far. All right. So these are prefixes. A prefix obviously is a prefix to a word. Um, and the ones I don't want you to really memorize any of these. Again, these are all from your online book. Awesome resource. You can read it if you want. But there is some I really do want you to know, and that you will use over and over. The kilometer, kilogram, different things. You need to know how to convert something. And I might be a little tricky person and give you in grams. And you guys need to know that the standard SI units is kilograms. So make sure if I give you grams, you convert it to kilograms, and we're gonna go over conversions later on, and you'll have it for classwork tomorrow. So kilograms, I need you to know kilo. I need you to know the base meter, centimilli, and everything else. I kind of just want you to keep in terms of SI units. So 10 to the 6, 10, like after you get kilometers, you wouldn't use kilometers. You would use the meter, and you write 10, 1 times 10 to the third meters, if that makes sense. And we'll go over conversions and what that means. So just real quick, 1 kilometer is equal to 1,000 meters, which is equal to the same thing in scientific notation, 1 times 10 to the third. If this confuses you, yeah, just come to me for office hours if this confuses you. Anyway, I'm assuming everyone knows this. 3 zeros, 3 zeros. Here's the 3 up here, 1 times 10 to the third. That's an easy way to do it. I might give you something like converting like 0.5 kilometers, which would be 500 meters. Just know your conversions. We're going to show you how to do the conversions later. I'm not going to ask you to memorize this. You guys can look it up. And I really care about you knowing your base units. It's pretty simple stuff. 1 kilometer, to cancel out the kilometers, you convert the kilometer, you put the kilometer here, you want to cancel it out, you put it on the bottom, you multiply it over. 1 times 1,000 would equal 1,000 meters. Excuse my bad writing. We'll worry about this in the future. So this is pretty simple stuff. And the only reason why we're spending a little video on this today is because we should know this. Yeah, and also remember, screw the imperial system. We should be using the metric. That's the takeaway from today. Is I don't like England. I don't like England when it comes to the imperial system. All right. So the takeaway is that also I do want you guys to look at your book. Alright guys, I had a little bit more to the video, but I just decided to cut it. It's unnecessary, and I'll make you guys for homework or classwork tomorrow to go through the different parts of the observable universe and the scales of size. It's fascinating. It's in your book. It's underneath the section 1.2 if you're curious on the online book. But I just wanted to make a really fast, short video just to cover some of the basic information that you should know. Hopefully this was just an overview and nothing is new, and the homework I assign with this is just a breeze. So with that, I just like to say peace, and I'll see you guys tomorrow.